welcome to module 3, where we are going to look at functions and modules. So we have 5 subsections, and the first one is defining functions using def, return, args, and quags. So args are just arguments, whereas quags are keyword arguments. So we are going to look at lambda, which is just anonymous functions. We're also going to import and use modules such as math, random, and OS, or operating system. Moving ahead, we're going to create and use our own custom modules. And the last section, we're going to look at exception handling using try, except, and finally keywords. And this is the overview of module 3. So this module will cover functions, Lambda expressions, modules, and exception handling. So each section will include practical examples and best practice notes. So stay along as we move to VS Code. So this module will cover functions, Lambda expressions, modules, and exception handling. So each section includes practical examples and best practice notes. So number 1, we're going to look at function fundamentals. So functions encapsulate reusable logic with clear inputs and outputs. So basic functions definition. So we use def keyword, for example, define greet name, and which one will return a personalized greeting string. Using f string hello name, and then for example we print greet Harry, and the output will be hello Harry. And we should note that use of doc strings, that is triple quotes or single quotes, to document functions. So it's essential to document our functions. So function names should also be lowercase with some underscores using pep8 documentation. Allow me to run this code so you can see our output. So py functions py you can see the output. This is the output. You're able to see the output as hello Harry. So let us move ahead. So in this section we're going to look at functions with multiple parameters. So for example, we have a function to calculate the area of a rectangle. Calculate rectangular area. So with length and width. So calculate the area of rectangle. It will return the length times width. So if we print calculate the rectangular area of sides, that's length 5 and width 3, we get output as 50. So note parameters act as local variables within the function scope. So allow me to run this code. Py functions.py. So I mistyped this one. It should be py, and you find the output as 15. Now in this section we're going to look at default parameters with values. So for example, we have a power function with a base and an exponent of 2 as the default value. So we raise the base to exponent power, which will default to this to be squared. So for example, return base star exponential. So and exponent, and remember exponent is 2. So for example, print power exponent of 3, you get 9 because 3 squared is 9. And if we take our own, we get it is 27. So 3 comma 3, we get it as 27. So allow me to print the result. So you see the output. Py function the py and we run. So the first output is 9 and the second output is 27. So if we change this output as 9 and this one as 7 for example, and we also change accordingly by functions.py, then we run, we get the 7 squared is 49 and 3 raised power 9, you get it is 19,683. So let us move ahead. So in this video, we're going to look at advanced function techniques, and in particular, star args, which will entail variable positional argument. So for example, we're defining the sum as the function to calculate the sum of variables, so which means a user can enter several numbers without any restrictions. So sums n number of numeric values. So for example, print number, and we need to return the values that the user enters. For example, 1 2 3, and then output will be, so they received 3 arguments and the result will be 6. So 1 plus 3, sorry, 1 plus 2 plus 3, you get 6. So we need to note that args become a tuple of a positional argument. Allow me to run the output and check the result. So pi functions.py, then we find that we received 3 arguments. So this is the line number 11, received a length of args, so which means this one 1 2 and 3, this is the length, and the output should be the sum, which means the sum of 1 2 and 3 is 6. So if we interchange this stuff, like this one to be like 7, and we print, we find argument is still 3, but the result is 12. So let us change the number of argument to 2. For example, let us add 5 and 9 and still print our function. So pi function.py, we run. So you can see 5 arguments and then the result is 26. So 7 plus 2 plus 3 plus 5 plus 9, then we get the result as 26. Hello guys, in this video we are going to look at quags, or variable keyword arguments, and we are going to have an example shortly. For define, we want to print a person with some keyword arguments, so we will print a person's details from keyword arguments. So for example, key value in quags.items, we need to print key to value. So for example, we need to print person name, for example, is Harry, arguments age is 28, and occupation, for example, is a Python engineer. So and we need to note that quags becomes a dictionary of key value pairs. Let me run the script and check the output. So pi functions.py, we run. So you see the result, names Harry, age, for example, this 28, and occupation, for example, is a Python engineer. So this is what quags example gave us. So let us have more examples as we move ahead. So welcome again, and in this video we're going to look at combined star args and star quags, or arguments and keyword arguments. For example, we need to we define our function as record event, event type, star participants, and star metadata, for example. So this one we want to log events with flexible arguments as the user will be providing. So for example, print event will be event type, and if we print the participants as participants, and we also need to print the metadata and its result. So for example, for key value metadata, we need to print f string and key value pair. So if we print the record of event, we find that meeting, for example, Alice, Bob, and the duration was 60, and location, for example, in Zoom. So alright, let me print the result as py functions.py and define the result as event was the meeting, and our participants were Alice and Bob, and then duration was 60 minutes, for example, and location was online, that is through Zoom. Hello guys, welcome again, and we're in section 3. We're going to look at lambda functions. So lambda functions are just anonymous functions. So are anonymous functions for simple one-line operations. So we're going to look at an example. For example, basic lambda syntax. As for example, we want to compute a square, so lambda is such that x is x to x squared. So if you print square as 4, that will get output as 16. So the pseudocode is as follows, which is equivalent to define square of x, and we need to return x squared. So we need to note that it is best for simple operations that don't need a full function definition. Let me run the script and find out our result. Py function.py, and we run. So we find out the result is 16. So if we change the value to 20, for example, and we run our function py functions.py, and we find the result as 400. So that is it, guys. I hope you understand what's happening behind the hood. Welcome again, guys, and in this video now we're going to look at lambda with multiple parameters. So for example, we need to calculate the hypotenuse. So lambda is such that a and b, and we need to square a and b before square rooting them. So if we print the hypotenuse of 3 and 4, we get the output as 5. So 3 squared, we get it as a 9, plus 4 squared is 16. So 16 plus 9, we get 25. So the square root of 25 is 5. So let me run the result and confirm our output. Py functions.py. So we find the result as 5. So if I change this to be 4 and this one to be 5, for example, so it will be 16 plus 25, then square root. We find the output. Py functions UI. You get that as 6.4 dot dot. So that is it, guys. Let us move ahead. Finally, guys, we are going to look at the final section of lambda. So using lambda with built-ins such as list and so on. So for example, numbers is equals to 1, 5, 3, 8, and 2. So we want to sort this list of numbers. So for example, sorted numbers equal to sorted numbers, key is equal to lambda, and lambda is mapped to x to negative x. So if we print sorted numbers, we get the output as 8, 5, 3, 2, and 1 as the output. Let me run our codes and confirm. So if we print pi functions dot py and we run, indeed we get the output as 8, 5, 3, 2, and 1. Now let us move ahead. Hi guys, we are moving to subsection 4 of module 3, and we are going to look at modules and packages. So this is importing standard library modules, and we are going to import math, which is a library for mathematical operations, and also going to import random and also, so from random we import rand int, which means for we need to do random operation, and from datetime we need to import datetime as dt, which is for alias for date operation. So if you want to use it, for example, print math.sqrt 16 .4 and then print randit 1 to 100, so random values from 1 to 100, and then you can also print dt.now.year, so to check the current year. So we need to note that when you use import module, we make it a general use. So and when you say from module import name, so this one is for specific function, and when we use as, we do create aliases for long names. So let us preview our stuff, and we find out that datetime is somehow long module name, so we use it as dt. So we can still use the name we want, but now this is the, you can say, the alias that is recognized worldwide, but you can shorten it the way you want. You can say dt, we can say datetime as, for example, d, or datetime as time, the way you want. And then from module import name, this one is example number 10 and line number 11. So from random, which means random has a lot of functions, so but we are only interested with random integers. Yes, random integers alone. So we can have random floats, values, but this module just need random integers. And then date from datetime, we need just to import datetime as dt. So, and we use this as an alias. So now and line 13 through line 15 is just outputting our result. So for example, line 13 says that print math.sqrt, that is square root of 16, is 4, and we need to print random values from 1 to 100, which means it will be 1 through 99, because the final one will be omitted. And if we print line number 16, will be at the current year, of which the current year as per recording of this video is 2025. So let me run the script and check our claim. Let us run our module and confirm the output by functions.py and run. So you check that the output is 4.0. The random integers, okay, sorry, so random integer for any number between 1 and 100. So we get it as, this time we got 57, and the year, as I told you, we are in the year 2025. So let me rerun again and we check if the value 57 has changed indeed. So pi functions.py, if we run, indeed you've gotten a different value, 16. So it is changing per each iteration. Then that's awesome. Welcome guys. In this section we're going to create custom modules. So we're going to have an example. So go to your file menu and create a new file. and you can save it as geometry.py and add the following lines of codes. So import math, which means we want to extract some mathematics functions. You can also define the area of a circle. So we need to calculate the area of a circle. So we need to return the math.pi times radius squared. And we can also calculate the area of a rectangle. So we need to define a rectangular area that's with length and width. We can also return length times width to get its area. So let us create our main.py. So in the main.py, this is what we want to add in. So we need first of all to import geometry, the file which is our module. So we want to print geometry.circle and geometry.circle area, and then we put argument as 5. So we can print the output and check the result. Let us check what's in our geometry.py file. This one is just a function, but we've not implemented anything. Just a function. So we are borrowing main. We are borrowing the function from geometry to main. Remember here we've imported this geometry as a module. So, and it contains all the functions to calculate the area of a circle and area of a rectangle. So we can still also do the calculation for area of rectangle. For example, if I say rectangular area here, you can also say print. So you can also print this one. Let me just copy this line. And print geometry dot rectangle area. So you we can copy this one and paste here, though it's not a good practice. So and let us put here like 20 and 12. So if I can run the result, let me expand my terminal. So if I can run this one as python main.py, you find that the area of a circle is this one and area of a rectangle is this one. It's 240 and 1256. Now guys, we're moving on to the last subsection of module 3, and that is exception handling. So we're starting with basic try except block. So we have a function here, try result is equal to 10 over 0 and except 0 division error. So if you get that 10 is not divisible by 0 error, so we provide our own error. So we need also to note that always catch specific exception rather than the bare except. The bare except means that the inbuilt error. The inbuilt error. So we need to create a human understandable error. That's why you use try except error statement. So let us try and run this code and check our output. So pi functions.py, we find that it cannot divide by 0. So what if I say result is equal to 2, 10 over 2. So pi functions.py. So we find out that it will not give us an error, but it will execute. Welcome guys again. We're going to look at how to handle multiple exceptions. So try, we have num is equal to int input, enter number, and want to print for example 10 over number, except value error, which we have to print in valid number format, except 0 division error. We need to print cannot divide by 0, except as e. So you can still print unexpected error as e, which means the inbuilt error. So I can check my indentation. The first trial is that we are asking a user to enter a number, and now we want to print the number out of 10 divided by such a number that the user enters. But the value we want to create our own error. So if we get the value error, so value error is an inbuilt error. So if we get the inbuilt error as value error, for example, instead of inputting integer, the user enters like a string. So we don't want to hear that value error from the computer, but we need to create our own error, customized from the computer error. So we say print invalid number format. Except zero division error. For example, zero division error arises when you divide a number by 0. So you get zero division error. So if we get zero division error, so the system, we need to print it as cannot divide by 0. Except we need to print the error, that is value error, as unexpected error, and print it as error. So let me run the script and check what's happening. So if I run my script, function.py, I enter the number. So if I enter the number like 1, I get the result as 10. So 10 divided by 1, you get 10. So let me run the number and now put 0. So functions.py run. So enter the number. Let me use 0. It says cannot divide by 0. So that one is zero division error. So now let me again try and run py functions.py and insert like 5r. It says invalid number format. So you see, this is how you create your modified error so that a user can understand what's happening behind the hood. So it's good practice to try and check if the system is indeed working as expected. So let us move to the next step. Hello guys, we're almost the end of this module, and we're going to look at else and finally clauses. So we're still looking at try. So for example, we want to open a file called data.txt in read mode. So content is equal to file.read except file does not found error, or file not found error. So print file not found. Else we need to print file read successfully. So if we also print the content, and then you can also print the final statement, which means you print cleaning up and file.close. So remember to close the file after reading. So file.close if file in locals, else none. So we need to return else returns when try succeeds, and finally executes a grade for cleanup. So you can see I'm having, again, I don't know what happened, but I'm having a number of indentation errors here, but I can fix this up. Now guys, we the function tries to open a file called data.txt in read mode. So in future we are going to look more on files, that's read, write, and append mode. So I'm just giving a gist about read mode. So file is equal to open a file called data.txt and in read mode. So we need to open the file, and if the file does not exist or is not found, we say file not found, and else we can read the file we say file read successfully, and you can also, which means we will read the contents of the file. So if I maneuver from my working directory, I want to check if I have that data. if I have that file, you can see the file is here and the content is hey everyone. So you can go back and close it. So it means if I run this file, I'm expecting to see something like hey everyone. So let me run and check what's happening here. So py functions.py and find it. File read successfully. Hey everyone. So cleaning up. So that is our final statement. So final statement must be executed despite whether you found an error or not. So this one is a mandatory statement that will be printed. And remember, after reading from the files, we need to close the file. So to use it in other sessions. So we need to note that else runs when try succeeds. So if it will not succeed, it means the system will the program will crash, but will get the printing function for finally. So let me try to change the name of the file. So let me change this name to something like uh, my data.txt. So my data.txt and then run py functions.py. If I file not found, cleaning up. So you find that it has not read the content within that file, but if we change that to be my data, it will still read. So I hope so you've now gotten what's happening behind the hood here. Now guys, let us have our summary from module 3. So functions are reusable code blocks, while args and quags are just flexible arguments, whereas lambda is anonymous main function and modules entails code organization. And on the other hand, try, except statements or functions are used just for graceful error handling. So module 3 is complete. Now go and build something. Let us meet in module 4. Please subscribe to our channel if you haven't, and also share our channel to your friends. Thank you.